The Calvin cycle. The light-independent reaction. What is photosynthesis?
Photosynthesis is a process used by plants and other organisms to convert light energy from the sun into chemical energy that can be later released to fuel the organism's activities.
Photosynthesis has two steps: light-dependent reaction, light-independent reaction, also called as Calvin cycle.
The light-dependent reactions occur in the thylakoid membranes, while the Calvin cycle occurs in the stroma of the chloroplast.
Light-dependent reaction. It takes place on thylakoid membrane. It is light-dependent and it produces ATP and NADPH as byproducts. Who is Calvin anyway?
He received the 1961 Nobel Prize in Chemistry for identifying the path of carbon in photosynthesis. There are three major steps in the Calvin cycle: carboxylation, reduction, and then regeneration. The 5-carbon compound RuBp is the first carbon dioxide acceptor. Calvin cycle begins with the input of carbon dioxide. RuBp reacts with carbon dioxide to form two molecules of 3-carbon compound PGA. PGA is the first stable organic compound of photosynthesis, also called glyceraldehyde 3-phosphate. Then reduction. PGA is reduced to PGAl using part of ATP and NADPH produced during light reaction. Electrons from NADPH reduce the 3-carbon compound. At the end, 6 3-carbon compounds of glyceraldehyde 3-phosphate are produced as the first stable carbohydrate of photosynthesis. Out of 6, 1 drives the formation of glucose, while the other 5 G3P molecules contribute in the regeneration of ribulose 5-phosphate. During this, ribulose 5-phosphate is oxidized to ribulose 1,5-phosphate by using ATP produced in the light reaction.
C4 pathway. It occurs in C4 plants to avoid photorespiration. C4 plants are more efficient in carbon fixation than C3 plants. C4 plants show the Kranz anatomy, in which the vascular bundle is surrounded by bundle sheath cells and mesophyll cells.
In mesophyll cells, carbon dioxide is accepted by PEP to form oxaloacetate, which is a 4-carbon compound and the first stable product of C4 photosynthesis. Oxaloacetate is reduced to 4-carbon malate and forms 3-carbon compound pyruvate and carbon dioxide in bundle sheath cells. This carbon dioxide reacts with RuBp and again drives the Calvin cycle, while pyruvate re-enters mesophyll cells, reacts with ATP to reinitiate the C4 cycle.
Created using Powtoon.